would you like to make a simply splendid night vision camera out of an old crappy webcam? I'm going to show you how I turned this shitty excuse for a webcam into an awesome night vision system that can work over 100 meters in total darkness. First, let's change the music to something less exciting and doesn't infringe any copyright. That's better. Today, most consumer products that feature a camera use what is called a CMOS image sensor. These image sensors are very good at capturing visible light, but they are also rather good at capturing infrared images. You can perform a very quick experiment whilst you watch this video. Just grab the nearest infrared remote controller and point it at your phone camera. And then you will be able to see the normally invisible infrared light clearly visible on your phone. Normally, camera units try to remove as much of this infrared light as possible by adding in a special filter. We are going to remove that IR filter, and then we are going to remove the visible light using a long pass filter, so that the camera can only see the infrared part of the spectrum. Before I show you how I did that, I am going to have a brief interlude to explain to you just how crappy the webcam is that I am using for this project. At the start of the COVID-19 pandemic, I assumed, like most people, that it would all be over in a couple of months. So when buying some webcams for our children's online classes, I was a bit of a cheapskate and purchased the cheapest ones I found. Say hello to the Gosu webcam and perfectly shitty device that I purchased two of for a grand total of $7 each. The Taobao advertisement promised high definition video, but actually delivered VGA resolution at about fuck all frames per second. Here is their video advertisement, along with my English translation.
Hello, and welcome to my video. If you are watching this, then you are a very old man. This camera comes with a really cheap box that costs nearly 15% of the actual product. Just imagine. This cheap camera has something called VGA, which was the type of camera used before I even born. It's so cheap that even poor grandfather can afford to buy. And it even had buttons that make it do 1990s things, like change picture color. How cool! It's amazing and it's so nice. It also have USB wire attached to camera, so old man not lose it. And instructions is with big writing so granddad can read it. Now you can make nostalgic video like this. Hello grandfather, look, I go back in time machine.
Okay, now I have gotten that off my chest, let's get this crap camera modified. I decided to buy a long pass filter, which will remove the visible light from the image. I have included the link to where I bought this in the comments below. Here you can see the long pass filter blocking the visible light from this flashlight. Because we are going to open up the camera, I have cleaned the work area carefully and I am wearing gloves. So, the first thing that we need to do is to disassemble the camera. Unscrew the lens. Usually the infrared filter is mounted to the back of the lens module. The infrared filter is a thin piece of glass with a dichroic coating applied to it. I used a sharp pair of tweezers to extract the infrared filter. With a little care it will pop straight out. In this case I managed to chip the filter, which is a shame, because I was hoping to use it for another video later. Now, reassemble the camera. And we are ready to add the long pass filter. Here is the difference in the image with the infrared filter removed. Because I have the patience of a child, I just use blue tack to stick this on for now. Later I will use some epoxy resin to bond it more permanently. Now what we need is some kind of infrared illumination to give our camera something to see in darkness. Initially, I just expected to buy a cheap IR flashlight, online, like this one. This flashlight has a great specification. Wow! 5 watts of infrared power, and only uses a AA battery. You have got to be fucking kidding me. Do you really think we are that stupid? So, infrared LEDs have a maximum efficiency of about 30%. This means that to get 5 watts of optical power, we will need 15 watts of electrical power from the battery. And this means that a little AA battery will need to deliver 10 amps of current. Which is clearly bullshit. Or in British parlance, a complete and utter load of bollocks. So what I am going to do is to convert an old white LED flashlight to an infrared source by changing the LED. At least, I will know what I am actually going to get in terms of performance. I will include a link in the comments below for the LED that I purchased. When I was looking at flashlights on Amazon, I noticed that there were a fair few that looked similar to the one that I have. When I say similar, I mean absolutely identical, except for a small brand mark on the handle. It is almost as though they were made at the same factory. Say hello to that factory. And welcome to the wonderful world of drop shipping, where highly reputable business people ply their trade when they are not giving English lessons to the locals. You will notice that the actual factory cost for these flashlights is somewhere between 1/10 and 1/20 of the cost you see on Amazon. How fantastic! Remember this, when China was being trashed by the Western news for selling face masks without Western certifications, it was these drop shippers that were the actual culprits. The flashlight that I am going to use was never a particularly good one, so I feel zero sadness with sacrificing it to this project. Once the main components have been disassembled, we need to remove the LED PCB and heatsink. This is made of aluminium, and this means that it is particularly difficult to solder, so use a large soldering iron, or a hot plate. I didn't manage to film the actual soldering. Once I had actually soldered it, I was not very inclined to return to undo the work I have just done, just to film myself burning my fingers again, for the purposes of entertainment. One point to note is that if you choose a different infrared LED, be sure that the specifications are close to the one I have used. In particular, pay attention to the forward current curve. If this is significantly different, then the LED will either produce almost no infrared energy, or it will burn out. We are aiming to get 1 watt of optical power. Once the flashlight is reassembled, you will be able to notice a dim pink glow when it is switched on. Here is a quick indoor test. The camera sensitivity is excellent, albeit with terrible resolution, and lots of optical signal noise. What I really want is a pistol grip device, which has the IR camera, the flashlight, and my cell phone mounted to it, which would make it very easy to use. I purchased this pistol grip and tripod combination for a super low price, and it even came with a free phone clamp. Now it is time to create some 3D for a bracket to hold the camera and the flashlight to the pistol grip. Time to print this out. If anyone wants a copy of the 3D file, please just ask in the comments and I will put it on Dropbox or something like that. Now I need to cut a length of 1/4 inch stud to mount the bracket to the phone clamp. I don't remember why I bought this length of threaded stud, but for some reason, I bought it made from the toughest grade of stainless steel possible. It took an age to cut this tiny piece. I also want to emphasize something about this project. I really want people to actually build this and let me know what they found. What improvements did you make? What model of webcam did you use? And what was the performance like? If you would like me to make more of these kinds of videos, please don't forget to like, and perhaps subscribe. What is most important for me though, is to learn how you got on with this project. Instead of measuring everything out and trying to be precise, I just clamped the bracket to the webcam holder, then cut away the unneeded part of the holder and then filed it flat. This saved a lot of time and effort. Next, I just drilled 2 holes through the back of the holder where the holes in the bracket are. Next, I reattached the webcam holder. I wanted to keep this part, as the ball joint allows me to aim the camera directly at the position of the infrared illumination. Then, it is time to attach the webcam to the 3D printed bracket, using the holes I previously drilled. I used self-tapping 2.5mm screws to do this. And the flashlight just clips into the bracket. Now, it is time to do the final assembly of the night vision camera system. This is where I noticed that there was a tolerance issue with the 3D printed bracket. The gap between the handle and the bracket was too high and allowed the bracket to rock from side to side. I fixed this by adding a strip of self-adhesive EVA foam to close the gap. Now it is time to tidy up the camera USB cable, and add a USB Type A to Type C adapter, to allow the camera to be connected to a cell phone. I used this free app, called USB Camera Viewer, to allow my new infrared camera to connect via OTG. And now it is time to go testing my new toy. Plant life seems to show up really well, under this near-infrared illumination. As you can see, the camera has such a lousy frame rate, that even small amounts of motion, causes blurring. I am really pleased, that I used a flashlight with a controllable focus. It really allows the device to work over pretty long distances. The only thing that I would really like to improve, on this night vision system, would be both, higher resolution for the camera, and a telescopic lens so that the camera, can use all of its pixels, even when the target is at a distance. However, I cannot be too disappointed with the results. After all, this was a webcam that I was contemplating throwing away. This has been a fun project, and I am already considering a version 2.0 device. If I was to do this again, I would use an industrial camera body that has 4K imaging and a C-mount telescopic lens. It would be a higher budget project, perhaps costing $150 to $200 US. If you would be interested in learning how to make that, please let me know in the comments below. Thank you for watching my little video. Please help me to beat the YouTube algorithm by pressing the like button, and if you want to watch more of this kind of video, just subscribe to be notified of new content.